faccio qualcosa più aleatorio, quindi... Okay, I think we can start the second part of this special section, TC9 concrete, innovative materials and strategy for structural integrity. The first presentation is by Daniel Suarez-Riera. The title of the presentation is Construction and Demolition Waste, New Life in Mortar Composites. Please, Daniel.
Good morning, I'm Daniel Suarez, a PhD student from Italy, and I'm going to present this work on construction and demolition waste and New Life in Mortar Composites. It's the beginning of the work, it's an ongoing work too. This work was divided into 5 phases, starting with the building industry, and moving to the construction and demolition waste and how to approach a circular economy initiative, the experimental activity, its result, and finally the conclusions. Starting with the cement industry, from the raw material extraction to the final product, the cement is has a high impact into the environment. Every year are produced around 2,250 million tons of cement, consuming around 4 gigajoules of energy. Most of this energy is produced from fossil fuel sources, emitting 1 ton of carbon dioxide for each ton of cement produced, and contributing in overall of the with the 5% of the overall global CO2 carbon dioxide emissions around the world. So to try to mitigate the situation of cement with the environment, some materials like supplementary materials or alternative cementitious materials, and also the manufacturing materials were implemented to try to replace some rates of the cement powder, the Portland cement, and help to improve its properties from the mechanical point of view or also from durability. However, from the point of view of the aggregates, they have been a little neglected during these years. And that's why in the building construction industry, for example, consumes around 40% of the raw materials extracted around the world every year. And only in the United States, for example, they produce, after this raw material was consumed, they produce around 300 million tons of waste from the construction sector. In the European case, we produce around 40% of all the waste in the European Union. And that's why we're trying to implement a circular economy approach, which is an initiative from the exploration to the final product to recycle and not just to stop at the waste. It's an initiative that could help the construction industry to be more efficient and from the point of view of the material consumption and waste management. In our case, we work with a construction and demolition waste sand that was produced in Italy, in Turin. It's a local product, which it's composed from particles from less than 80 microns to around 30 and 40 millimeters. And this particular property that it has an water absorption capacity of 5%. It's known that this property can affect the final property of cementitious product like a mortar or concrete. In our case, specifically, we work with this fraction only, the other fraction that are present in the standards and that is usually used for mortars, from 1.6 millimeters to the filler one that is less than 80 microns. For this research, specifically for the mortars, the material used were the ordinary Portland cement, tap water, super plasticizer, and I'm going to explain why we implement this additive. the standard sand obviously, and the construction demolition weight sand. First, 5 batches of samples were prepared, starting with the reference one, in which just standard sand were used, moving to 5% of substitution, the standard sand with the construction demolition sand, 50%, 75%, and 100%. It's important to notice that for the substitution, each particle size was substituted one by one, and not it was first the sand was sieved and each size was replaced with the construction demolition weight sand. During the mortar preparation, we had some problems with the lavability or workability, and that's why it was, I said before, that we used an additive, a super plasticizer, because it was practically impossible to cast the mix. And in fact, there was also a segregation episodes in some samples, and these samples were not taken in consideration because it was impossible. There were no perfect at all. There have some voids inside the molds and so on. That's why then a super plasticizer was used to work in the same environment of workability of the mixes. And after that, we can see here the mix design used for each type of sample prepared, from, as I said before, with the different rates of replacement of the standard sand, and the doses are with the super plasticizer, arriving to in the case where 100% sand was replaced, to 6% of super plasticizer used by weight of cement. And we know there is also a high rate of high amount of super plasticizer. After 7 days and 20 days, well, that was the curing time, the flexural strength, the 3-point bending test was performed to evaluate the flexural strength, and it was possible to observe that there was an improvement in the initial phase of the material, arriving to an improvement of around 10%. However, at 28 days after curing, we obtained like a steady result. There was an stabilization in this property. Regarding the compressive strength, the improvement were obtained in both cases from 7 days and 28 days, arriving also in this case from an improvement from 6 to 10%. And also there was a slight improvement even when the standard sand was completely substituted. In this case, these results were obtained because, like I said at the beginning, the construction demolition weight sand has this property that can absorb water, and at the end the effective water to cement ratio was not the 0.5. I forgot to notice that all the specimens were prepared following the UN standard that specify that we have to use a fixed amount of cement, a fixed amount of aggregate, which is 1:3 ratio, and a 0.5 water to cement ratio. So in this case, when the construction demolition weight sand can absorb a certain amount of water, the effective water to cement ratio can decrease to 0.39 or 40. So this contributes to obtain a higher mechanical properties, because there was less water available for the cement aeration process. To conclude, we can say that the bad part from using the construction demolition waste sand is that it significantly impact the mortar workability, and we have to use additive. And like I said before, for the cases like, for example, the 100% replacement rate, there was a high value to use. Usually in the cementitious materials, we use like 1 or 2% of, and not driving to like this 7 or 6.5% of additive subplasticizer. However, it facilitates a sustainable production of a construction material that usually you are only using raw materials, virgin materials, and now we can improve also the waste management in the construction industry. And this can help to conserve landfilling space, because usually the construction demolition waste is a material that can be used, for example, for filling the road pavement construction, but high amount of this material usually in landfilling areas, and taking it back from that side to produce a new material to implement it in the concrete or mortar specimens helps also to reduce the carbon dioxide emissions, with obtaining also a material that has in some way a mechanical properties improvement, since even when the 100% of the sand was replaced, we obtained the same mechanical property for the reference with a completely recycled material. And this obviously promotes an application of sustainable mortars, and promotes future studies. That actually this one is a study that is ongoing. And there are other topics that have to be evaluated yet. So it was like a brief of where are we doing now.
Any questions? Please.
It's not very scientific. From curiosity, maybe. Yes. From the financial point of view, using this technique and the traditional one, what is the rate?
In this case, this case is waste. Is a waste. This one is a waste that
But you have to do some preparation before using it.
Yes, only the preparation is you have to sieve this sand to obtain the same curve of the standard
So
sand.
it's lower, the cost is lower compared to traditional.
We haven't made yet the analysis around the cost. We're planning to perform an LCA analysis.
Thank you.
Probably you have to use more chemical additive principle.
Is it expensive?
I don't know how much that's.
We haven't yet performed the
I
cost
mean,
analysis.
for
yet.
free at this moment. Company.
Yes, that was it's one the problem, because you have to use a high amount of additive in general. So maybe you can, in some way or another, save some expenses, but you have to take it from another point of the material. So the thing is to try to find the balance between, maybe you don't have to replace the whole sand, but maybe with 25 or 50% of replacement, you can obtain a material that is sustainable from the environment point of view, also from the economy, from the cost point of view.
Other questions? Okay, thanks.